In this example, we want to take the integral, the definite integral, from -2 to 3 of e to the negative x. So the way I'm going to solve this is I'm not going to use substitution. I'm just going to use that property where it's just like 1 over a times e to the ax. So we're just going to use that to integrate it because it's just -1x. So we don't necessarily need to go through the whole substitution process. So what this is going to become then is 1 over -1, which is just going to be -1. So I'll just go ahead and just write this as -1 because it's negative a. If you want to think of it like that, like -1x, the a is -1. So then e to the negative x, we're going to evaluate that from -2 to 3. And then we just want to plug in our limits of integration. So I'm going to have negative e to the -3 minus, and I like to just get in the habit whenever I'm doing definite integrals, I just get in the habit of always just putting that second part in parentheses in case it's something like negative e to the negative x plus 5x or something like that where we have multiple spots where we need to plug in that value. So that way I just don't make any sort of mental error where I forget to subtract off everything. I just get in the habit of always putting that parentheses there. So I'm going to plug in -2. So I have negative e to the negative times -2. It's interesting there. Times -2. And then close that up. So let me just clean up these negatives and everything first before I start to rewrite some things. So this is going to be negative e to the -3. Negative minus is going to make it a plus. So minus and negative is plus. E, same thing here. -1 times -2 is a positive 2. So then this needs to be rewritten though, because you never really want to leave your answer with a negative exponent like that. So we want to move that down. The -1 can just stay out in front or stay on top, but either way, there's nothing going to be left on top. So we just need to placehold that with that -1. Just put the negative out in front if you want. 1 over, it's going to be e to the 3rd plus e squared. And I'm just going to leave it like that. You can get an approximation as a decimal value, not the biggest deal in the world if you leave it like that. And if you did get the decimal approximation, you get 7.34, we'll call it. Oh, but I think a lot of textbooks will probably leave it in this form. I don't know, I guess it kind of depends on what you're trying to get done. If it's like an application question, then you definitely want to translate that. But if it's just doing a definite integral like this, like I think this is perfectly fine. But applications definitely want to approximate that. So yeah, it gets a little weird with that negative. You got to be careful with that negative there, and that's just using that 1 over a e to the ax, where we just want to offset that because chain rule of e, when taking derivative of e to the ax, it's chain rule, so we want to offset that with 1 over a. Good example there.